Good morning, all. I'm Z Yasso, and today I'm going to tell you a story about how a company scaled from a humble hackathon project to a globe-spanning abomination that no human can hope to understand. One of the biggest memes in the industry is this idea of scalability. A lot of the times when you hear people talk about scalability, you have an entire industry of consultants that end up with diagrams like this. This is the AWS reference architecture for an Internet of Things Tamagotchi. The big problems with diagrams like this is that they tell you where they ended up, but none of the story of what was taken to get there. It's not really fun if you only hear the end of the story. Who just wants to find out that the dog dies at the end of Marley and Me? This leads to one of my least favorite interview questions ever. How did we get here? How did things get this complicated in the first place? The last time I remember doing this question in a job interview, it was on a whiteboard and took about 3 hours to start with a single server and rederive production. And the interviewer just sat there, almost trolling me as he threw circumstance after circumstance at me to get me to independently make the same decisions as they did when they led to production existing as that day. If you've never had this interview before, it is ritualistic hazing. It's terrible. But today, I'm going to tell you the story of a startup called Shashin. Think of Shashin as Instagram, but not. But before we get into that, I'd like to introduce who I am and my background. I'm Z Yasso. I am the senior techno-philosopher at Fly.io, where I founded the developer relations team. I blog a fair bit, as my friends and loved ones can attest. However, I'm not actually a technical writer by nature. I'm more of a fiction writer. And that is how I'm going to be telling the how did we get here story without breaking any NDAs. I've split this story into a few eras that will help you exemplify the scale of a website or app like Shashin's development. I start with the hackathon entry, where then I'll describe the small-scale implementation on AWS, and then I'm going to explain how and why things become globe-spanning abominations against mankind. Once we get to the end, I'm going to talk about the ways that I would build Shashin off of technology you can just grab off the shelf today. By the way, legal told me to say this, but so we are absurdly clear here. This story is a work of fiction. Any names, characters, businesses, places, events, and incidents in this story are either the project of my imagination or are used in a fictitious manner. Any resemblance to actual persons, living or dead, or actual events in your observable reality are purely coincidental. Also, when I tell this story, a lot of the irrelevant technical bits will be replaced with funny words just to make you laugh. If you recognize what one of these words is supposed to be, please raise your hand or laugh. It makes everyone have a good time. And I'm going to be using the word you in this story. You does not refer to you, the person. It's more of like a second-person generic you that English doesn't have the right inclusivity for. But I'm also referring to a character. Just imagine the character as someone like this, a startup founder of the era who stumbled his way into success. Oh, by the way, as you can tell, the story's going to have humor. So if you think something's funny, laugh, because my SRE jokes sometimes flop really hard. So, the year is 2009. You and one of your best friends have decided to go to this new thing called a hackathon. Hackathons only recently started up, and this one is powered by Takaro and Z Combinator, and they have a $5,000 cash prize, which sounds really good to you. Your friend has been playing with this new mobile phone OS called Actroid. You both have a background in photography, and you decide you want to make something that includes photography in the competition. Every Actroid device is equipped with a high-power camera. It's nowhere near your DSLR, but it's good enough. Every Actroid app has to be written in Espresso, but you don't have to write your backend in Espresso because Espresso sucks. Espresso is verbose and complicated to make simple things, and this is a hackathon. You're on a time limit. So, arbitrarily, you picked Python because you went to a meetup once and you thought the people there were nice. This is how these technical decisions get made. One of the big advantages of Python is it has SQLite right in the standard library. This makes hacking easier because you don't hate yourself enough to set up Postgres on your MacBook, especially of that vintage. So, you and your friend hack it up and you make it work. It's time to show it off. You pull out your phone, you take a picture, you upload it, your friend pulls down the thing in the Android or the Actroid emulator to view it, and the crowd shows up on the projector. The audience erupts into cheering. You win the hackathon, and sooner than you can imagine, investors want to talk. So At this stage, here's the whole situation of everything going on. The backend runs on one developer's laptop. This is really great from a development standpoint because it makes it really easy to hack on. However, if that developer laptop gets hit by a meteor, you have to start over from scratch and there goes all of your data. That's probably not the best. There's also an app written in Espresso for Actroid. The IP address and port for your laptop are hard-coded to the IP address and port of the developer laptop on conference Wi-Fi. It barely works on a good day. However, this doesn't matter because you won. Relish in the peace of the victory. It will be some of the last peace you will have for a while. Things are getting serious. With great investment power comes great responsibility to your users. So you go out and survey the options for running this thing somewhere reliably, but it's 2009. Let's face it, you're going to choose AWS. AWS actually lets you pay for what you use, which for 2009 is so unheard of that it literally created the cloud. One of your investors suggests that you should use Postgres for your database instead of SQLite because they read the Heroku blog once and they said something that could be interpreted in passing as Postgres better than MySQL. These are really how these decisions get made. As you work and get advice from different advisors and investors, you end up with something that kind of sort of looks like this. This basic 3-tier infrastructure is the kind you see people reinventing over and over, all over, everywhere on the planet. Servers are broken up into 3 tiers: routing, application, and storage. Your routing servers take in requests from the outside world and turn them to application servers. Application servers turn those requests into responses, and in the process, they might poke some of the storage servers to do things like query Postgres or upload files or something. So, the Actroid app is how users look at and upload photos. Whenever the app needs to make a request, it'll send it to the routing servers. One routing server will be chosen at random thanks to the power of DNS, and it'll send it over an internal network to an application server. The application server, as I said, poke Postgres, return a response. But there's one bypass here. This is a photography thing. Statistically, 50% of requests are to view photos. So you can bypass the Python single thread limit by just directly forwarding photo requests to the photo server. Also, at the time the Actroid app was implemented, it didn't have the ability to write to the camera roll because that API call wouldn't be released until 2011. The file storage server has the only copy of a lot of your images. But AWS is robust, right? It wouldn't just go down randomly, would it? Would it? Wrong! It's 4 a.m. and you wake up because everything is down. Raise your hand if this is relatable. This time in the pager zone, everything is down, and when people go to the website as a fallback, they see this image. Your app is breaking amazingly, and everyone sees someone scolding a router. Users are complaining on a service originally made for commenting on podcasts over SMS, but I think they call it Why Now? A heroic effort ensues, and the application is brought back online. However, in the wake of this, you realize that some of the images are corrupted. You got lucky. It was only the last few images before the storage server literally exploded. But this corruption scares you. You have the only copy of your users' photos. The image storage server was bullied into submission by people just taking pictures. In your postmortem analysis, you realize that it's probably not a good idea to have all of production hinging on a single server that might just go down at any moment. And for some reason, to add the fun, if your storage server goes down, your backend goes down. This is not good for uptime. You ask one of your investors on a whim, and they suggest you use this thing called Simple Storage Service for uploads to a server instead of a bunch of files like you used to. Unlike a lot of things with simple in the name, this is actually good, and it allows you to put bytes to the cloud with a name and then use the name to get the bytes back. It's like an unlimited FTP server. S3 saved the day. With this, you're more easily able to trust that one server going down won't destroy user data. However, at the same time, AWS at this point in time is the only platform with something like S3. If you ever wanted to move off of AWS for some reason, S3 would keep you locked there with terabytes of data and egress per gigabyte. At the time, the team is about 16 people, including you, the CEO, and I think you have a marketing person. This is still small enough that everybody can keep the idea of what's going on and who's relevant for what in their head at all times. However, 2 words are about to change this. The big pile of money has slowly started to run out. In order to keep the company online, you need capital. You pass the great filter with a Series A round. And just after you announce everything, you get viral, you get more users, the pager goes off multiple times. People can't upload photos, but they can sometimes view existing ones. It's worse than you thought. The database server is falling over. Every additional user you get makes the problem worse. Somehow you manage to fix it. But in the post-mortem analysis, you realize that you're making a lot of the same SQL requests over and over and over in a loop. If you could somehow save the results of those queries for a little bit, you could make fewer requests to the database. So again, you ask a different investor for advice from the Series A round, and you hear about this little program called Valky. It's you can use it to put database requests in there because everything's stored in RAM and everything's going to be great and happy and fun puppy sunshine, right? But this does buy you enough time to figure out what you're going to do with your database server. So Valky is now a permanent part of your tech stack. It works great, and you're really happy with it. Until 4 a.m. rolls along again. You shake off the grogginess and you realize the horror of what has happened. Valky crashed while saving its database to the disk. Valky is in memory, but it makes disk snapshots so that when it restarts, it can resume right where it left off. Crashing mid-save means it got corrupted. The cache is gone. All the clients are constantly making complicated SQL queries over and over, and you've just created a thundering herd problem. Achievement unlock. However, thanks to the fact that you bought some time with Valky, you were able to set up a read replica. You, in a fit of madness ensued by coffee and whatever you put in your sugar, you decide to make the read request randomly go between the primary and the replica. This gets the app back up. This event soured the taste of Valky in your mouth. Thundering herd problems, let's be clear, they suck, they're hard to predict, they're really easy to see when they happen, and they're really hard to mitigate. It is a terrible thing. You can do it totally by accident and only find out 3 months down the line. So now the back end looks something like this. It's getting a bit more complicated, and your experiments that you were trying because you had some free time, guess what? They're now permanently part of production and critical assets that can never be destroyed. You're about to hit the limits of your existing Postgres setup because database replica is also on its last legs. You need more replicas and fast, and you've gone viral again. Someone tells you about this configuration management tool called Aerodactyl. You create a database server by hand, fossilize it into Aerodactyl, and make 5 more. Works perfectly. You adopt Aerodactyl across the fleet. As this happens, you hit another inflection point that is another great filter for these companies. The transition from the big small team to the small big team. People are starting to specialize and corner themselves off in parts of the app. And this is the point where you usually see those people form teams. And then, as those teams get formed and everybody has their own agendas, you run into problems with your version control system, Ruffian. When multiple people are modifying the same files at Ruffian in different yoink requests, you get conflicts. This was academically interesting the first time, but by the 500th time, it became the thing that stopped you from doing anything. Switching away was impossible because Bitbucket deleted Mercurial. And these kinds of conflicts are how you end up with the M word, microservices. Your backend gets carved up into different parts maintained by different teams with their own different agendas and their own different release schedules. In an ideal spherical cow reading of microservices, every microservice has a well-defined API that it uses to collaborate with other microservices to help assist in the process turning requests into responses. Does this happen? Scholars continue to debate to this day. The image uploading team, they were patient zero. They were having reliability issues when the monolith was having a spate of seg faults and users were complaining that they couldn't upload images. They split it out into a separate service as an experiment. They shipped it into prod as one does, and it worked. Other teams started to run into conflicts. They got fed up. They made their own microservices, and it solved that organizational issue. But it's worth noting, microservices are not a universal team scaling cure-all. Microservices can make things more robust, but it can also make failure really difficult to detect because sometimes things will be working and sometimes things won't. So now with the microservices in play, your backend looks like this. It's a mess of hell that just looks terrible. Everything is getting carved out, and the monolith is basically handling user logins and comments. As you grow, you're running into another fundamental problem that you can't really work around. You've been trying to avoid it, but you have to confront it. The speed of light. Computers are fast. The speed of light is 100 milliseconds from Virginia to Europe. You need to expand it to multiple regions. This is the great filter for these kinds of applications. Making a true distributed system like this comes with a lot of problems that you get nowhere else, and nobody can help you unless they're Google, and even then, Google can't do it right. However, you got really lucky due to the pattern of user requests and the design of your stack. The majority of things that are slow involve reading data, so your multiple regions are really just caches. Whenever those things need to make a change to the main server, they'll poke it over a VPN, or they'll poke the main base over a VPN or something. This makes it relatively trivial. Well, as trivial as globally distributed systems can get. However, once you go past this point, you have reached the point of no return. Nobody is able to understand anything that is going on anymore. Like this humorous thing from Krazam, they could actually understand it because they drew it all out, but once you get to global multi-region, yep, good luck. This is probably the point where you're thinking about having something like Kubernetes in the mix. At anything below this scale, it's probably not the best use of your time. However, you have a bigger problem. Your cache is finally starting to run out, and your only exits are to sell or go public. Either way means you get to retire. After entertaining a couple offers in the private market, you sell out to Hieroglyph. You get to retire at 45. You win. The infrastructure is someone else's problem now. As I promised, I'm going to tell you how I designed something like this in the real world for that relatively simple medium to small scale before we go all, demon summoning ritual in the infrastructure diagrams. I'd probably end up doing something like this. Note my bias is that a lot of the technologies here I'm getting paid to shill, but realistically, this is the stuff that you need. I'd have the main monolith handle everything, of course, because I don't hate myself that much. But the image uploading thing would be the only part that I would split off into a separate component just for the speed of light. Image file format conversion is also one of those worst case scenarios where it's both CPU and memory intensive, so you definitely want to shunt that away as much as possible and have other things handle it, like queue workers or dynamic machines or whatever. And all the images would be stored in Tigris as an S3 and a CDN in a box. Having the uploader service in every region means that the files would be in the regions closest to the user by default. If you're in Seattle, why should you have to upload your photos to Northern Virginia to view them in Seattle? What sense does that make? If you have any questions about this setup, please see me in the hallway track. You can see my hoodie from Orbit. In conclusion, there's a couple things that I want you to take away from this talk. The complexity that you see in the backends happens for a reason. Every diagram has a story. Unless you're at the stage of a globe-spanning abomination, you probably don't need Kubernetes, but I'm setting up a Kubernetes cluster in my home lab, so who am I to talk? And finally, storage is one of the most annoying things that you will ever have to work with and will only get more annoying as things get more complicated. Before I finish this up, I just want to take a moment to thank everyone on this list for helping me make this talk shine. Your efforts have been noticed and you are loved. And thank you for listening. I've been Z Yasso, and I'm going to be wandering around the Tigris table. Like I said, you'll see my hoodie. You can ask me questions there because I have 30 seconds left. If you want stickers, I got them. Have a good day, everyone.